Hey, Alex, welcome.
Hello. I'm live. Hey, Joe. Thanks for having me on. Great to be here.
Great to have you. Really excited by your session. As I said, it's pre-recorded, but before we jump into it, anything you want to mention, maybe to hype up? You are the DynamoDB expert. You wrote the book on it. So any thoughts?
Yeah, for sure. Yeah, I would just say one thing I've been really like passionate about over the last year, 2 years, 3 years is just like thinking about cost when you're modeling with DynamoDB and thinking about that. I love how Dynamo like makes that predictable and apparent to you, so you can like trade off or think about different trade-offs as you're modeling things out. So thinking about this one's especially focused on like secondary indexes and how to optimize those. Should I have one? Should I replicate everything into it? What should I think about projections? All that sort of stuff. So we get through some numbers. Like I think it's really fun to go through and like see the light bulb turn on for people there. So I hope it's useful. Be sure to like add any questions, because again, we'll have 5, 10, 15 minutes after that we can talk more about some of this stuff. But yeah, really excited for today.
As am I. So thank you again, Alex. Alex will be here. He's my security blanket. If for any reason I have a question I can't answer, or we just need some expert insight, I'm going to be pulling him into the stream. But Alex, here's your recording followed by live Q&A. Thank you again.
Cool. Thanks, Joe.
Cheers.
Hello, everyone, and welcome to DynamoDB Day. Super excited to have this. We've got some great talks today from people from the DynamoDB team. We've got people from Eon. We've got people from Capital One and Ubisoft talking about their actual experiences building with DynamoDB. And I'm excited about it because I love DynamoDB. I love talking about it. I think it's really interesting. I'm Alex DeBrie. I'm an AWS data hero, do my work with DynamoDB, and I also do consulting and teaching and training around Dynamo. And you know, when I go to a company and do some training and stuff like that, you know, especially if people are new to Dynamo, I often start off with this saying, hey, Dynamo is a fully managed NoSQL database provided by AWS. And I think that's interesting, but a lot of people focus on just that NoSQL database part and use that to sort of categorize the world, right? And they sort of divide the world of databases into two things, where you have SQL, you have your traditional RDBMS databases on one side, and that's Postgres, that's MySQL, that's Oracle, SQL Server, whatever you have there. And then on the other side, that's where you have NoSQL / everything else, right? Which of course includes DynamoDB. It also includes things like MongoDB, but also like weird things like Elasticsearch and even, you know, Redis, if we're talking about caches and things like that. And that's a fine way to divide the world, but I think you end up grouping stuff together that doesn't really make sense. And I saw a tweet recently from a guy I really like, Dylan. He works at Vercel and built this Vercel domains project using DynamoDB. And he's talking about how learning DynamoDB this year was huge for him. And he used to think it was just AWS Mongo. And I think that's a lot of people's intuitions, right? Where it's like you have these NoSQL databases and like DynamoDB and MongoDB are very similar. But I actually think that's like not a really good way to break up the world is between the SQL and NoSQL, right? And I think a better way, there are lots of ways you can sort of break up the world of databases, but a better way, one that I think about is databases with a query planner versus those without, right? So databases with a query planner, again, you're still going to have all your SQL relational databases over there on that side, but you're also going to have MongoDB and Elasticsearch, where even though they're more in that sort of NoSQL camp, they do have a query planner. And I think that distinguishes them from the databases on the other side, which are databases without a query planner, right? And that's where you get DynamoDB. Probably the biggest other name in here is Cassandra, which has a lot of similarities and overlap with DynamoDB. And then you get like, hey, there's Convex, which is newer, doesn't have a query planner. There's also Redis, again, not really a database, but allows you sort of direct access to these items, right? And I think this split is more useful when you're thinking about how to learn and use DynamoDB well, right? And I think the biggest thing is like with DynamoDB, you are the query planner, and that should change how you're actually modeling and thinking about your data, right? So that's what I want to talk about today. We're going to talk about cost-aware modeling in DynamoDB and sort of how to be thinking about your costs and being the query planner when you're modeling with DynamoDB. There's a book out there called Seeing Like a State that some people like, and the alternative title I had for this talk was Seeing Like a Database, right? Where you're actually like sort of being that query planner for your database and seeing like a database. I thought maybe too niche, so I didn't call it that. But anyway, what we're going to talk about today is just like the what and why of being a query planner, what a query planner is, why Dynamo doesn't have one. And then we're going to get into like the implications of that and what that means for you as you're planning. And then the biggest part of this is just like an application section where we'll look at sort of a real life application and do some modeling with it and think about, hey, how can I be thinking about cost as I'm actually doing that modeling? All right, so let's get started with the what and why of being a query planner. Again, we're separating those world into databases with a query planner and databases without. I want to take away a few of them and really like, hey, if you're thinking about OLTP transactional data that we're talking about here, these are your main options, right? You're going to have SQL and MongoDB on one side, and then you're going to have your other databases without a query planner, Dynamo, maybe Cassandra on the other side, right? And we talk about a query planner, those databases with a query planner. What I mean is, hey, you're going to send across a query, something like this, right? Some SQL text or something where you're saying, hey, select star from the products table where the category is electronics, right? Maybe you have some e-commerce store and you just want to show the electronics and it's doing that for you. Or maybe you even have a little more complicated one where you're selecting from the products table, you're joining it to another table and filtering on attributes from both of those tables. The big thing here is, hey, you don't really have to think about how that data is laid out on disk or arranged or anything like that. You just sort of declare what you want. And the query planner under the hood is going to sort of arrange and gather that data for you, right? And this is in the SQL instance, but like also if you're using MongoDB, it's going to have different syntax, but the same thing is happening. If you issue a query like this, hey, from my products, find, ones that match this category and this manufacturer name, maybe you've denormalized it on there. They're still going to figure out, hey, which indexes should I read from? Which tables should I be scanning from or different things like that, right? So query planners, actually really good things. I don't think that query planners are bad, and especially they provide flexibility, which is really nice, right? You don't have to think so down to the physical layer of like, how am I laying out my data so that I can access it? It's saying, hey, normalize your data in some sense and set up your indexes and we'll sort of handle how we actually access that data, right? So they provide that flexibility on one hand. On the other hand, they also add unpredictability, right? Because you can have a database that's running its query plan pretty well, and all of a sudden it changes, you get some sort of alert, or maybe even just your data distribution changes, and it adds some unpredictability there. My bigger beef with query planners, though, is that they hide complexity from you as a user, where you don't really have to think about as much what's going on, or you can get away with not thinking about it, and it can come back to bite you, right? And one way I sort of think about that is even with our very simple one where we're just selecting from that products table and filtering on a particular thing. Hey, we're selecting all the attributes here, which might be fine for a while, but now we're in this new like AI world. Maybe we add like a vector embedding on this table, right? We've got this new column. It's this giant 4096 dimension embedding on it. And now you're pulling that back and it has maybe that column is like toasted off onto another table. You're like hopping all over the disk to go fetch that. And this query that used to run pretty well is now a lot slower, right? Or if we have that query before that was joining different tables and filtering on different things, maybe that's running pretty well. But now you add this new order by, you're ordering by the product rating and then the manufacturer rating because you want to show like the highest rated products first. If you don't have the proper indexes set up on that could be like full table scans on this data. It could really blow that out for you, right? So it hides complexity from you, which is something that I don't particularly love, adds that unpredictably as your data sort of changes over time. And when you get down to it, if you're talking about OLTP at scale, predictability is better than that flexibility. That flexibility from that query planner is nice when you're prototyping and starting to think about stuff. But once you start getting into production and getting more and more data, you start to like that predictability because you need less flexibility on your data at that point, right? So given that, I talk about how Dynamo doesn't have a query planner. And what I mean when I say Dynamo replaces the query planner is what they've done is they've sort of given you a set of features that rather than relying on this query planner, you're sort of directly laying out the data in a particular way and accessing it directly, right? So some of the features or limitations that they give you is this smaller, simpler API where rather than allowing you to send in this text string and sort of query any data you want, hey, you can do simple CRUD operations on a single specific item. You have to give it the exact key to know exactly what to look for there. It's also got this query operation where you can fetch many, but even in that sense, you have to provide a partition key and you have to get just sort of like an ordered range of items, right? So it's this smaller, simpler API rather than this more flexible API that can do joins and other things like that. Additionally, you have to specify the table or index to use when you're actually querying your data, which again, with that SQL database, you don't have to specify that, your database behind the scenes, it knows all the indexes and can generate some sort of plan for that. But with Dynamo, you have to say, hey, I want this specific table, this specific index. So there's no surprises about like what's going to be happening there. Similarly, they also limit the amount of IO you can do on a single request. So if you're doing that query operation and want to read a bunch of items, you can read only a megabyte of data before it's going to return to you and say, hey, if you want to keep reading, here's a pagination token, but you have to come back and get more in the next request, right? So they're limiting, you don't have this sort of unbounded, unknown amount of work that can happen on a single request. And just like they limit your IO, they also limit your compute, right? There's no joins, there's no aggregations, anything fancy like that with Dynamo. So you can't have, again, unbounded and unknown operations. So my mental model of how to think about Dynamo is like, hey, they give you this infinite pool of storage that you can write to, but you need to sort of lay out your items within that storage to where on a single request, you get one contiguous read from a single storage node, right? So which means you can go read a single item as long as you can directly identify it, or you can read a range of items, but you need to make sure those items are located together so you can do just one contiguous read, right? And that's not exactly what's happening under the hood, but in terms of mental model, I think that'll get you pretty close there. So that's the what and the why about a query planner and how Dynamo sort of gets rid of that. I think let's move into the implications and what it means for you. I talk about Dynamo, you are the query planner. A query planner is doing a lot of different things. It's like parsing your SQL, it's normalizing your query and things like that. But the big thing it's doing is really cost optimization, where it's keeping statistics and histograms about your data and the distribution and things like that. When you issue a query, it's going to look at those statistics. It's going to think about the different indexes you have and generate a few different plans about how expensive this query is going to be and try and find the cheapest way to do that, right? So it's like this cost optimization, which that's what you're really doing with Dynamo. You are the cost optimizer and thinking, hey, what's the cheapest, the fastest way to do this, and laying out your items in a particular way to do that. So when we talk about cost optimization in DynamoDB, there are two things I like to think about. Number one is just latency, right? How do you want to reduce the latency of any particular set of actions you need to do in Dynamo? This is basically what your relational database is doing, is trying to reduce the latency, the cost of any particular application, right? So when we think about optimizing DynamoDB latency, one nice characteristic of Dynamo is just how it gives you predictable performance at any scale. So you should sort of have these like client-side latency numbers where in your application, this is, sort of the upper bound for what you should expect from a DynamoDB operation, right? A read operation like a get item or a query, probably 5 milliseconds at the worst and probably less than that. If you're doing a write operation, maybe 20 milliseconds. If you're doing a transaction where you're writing multiple items in a single request, now you're looking at maybe 100 milliseconds at the worst, right? So just having those on the tip of your tongue and thinking about those as you're thinking about how to handle given access patterns. And just some latency optimization tips. I think the biggest thing is you want to avoid sequential requests in Dynamo, right? I think some trouble that people get into is they normalize their DynamoDB tables a lot. And now when they have to do a read operation, maybe they need to read an item from one table, look at that a lot, and now hop over to a different table, read some items based on that, and based on some attributes there, go read from a third table. You want to avoid those sort of sequential waterfall type requests because that's where it's going to hit you with Dynamo. What you really want to do is, hey, where can you sensibly denormalize, maybe duplicate some data so you can avoid those sequential requests and maybe do it in one request or two requests that can go at the same time, right? And on that same point, you don't want to rely on heavy pagination of your requests, right? If you have to be fetching a range of items, right, and maybe there's some filtering on that, you don't want to be sort of fetching a meg of data, looking through that, fetching another meg of data, looking through that, fetching another meg, and be counting on heavy pagination. You want to set up your indexes, your keys, so that you can filter based on those rather than having to paginate through a bunch of data. So that's how we think about sort of latency optimization in DynamoDB. But the other type of cost optimization that you can do in Dynamo, what we're going to focus on in this talk, is around billing, right? Where you can actually optimize your DynamoDB bill. You can, there's a very direct connection between sort of what you're doing and what your bill will be, right? So I think it's useful to know just some basic billing numbers for DynamoDB. And the biggest thing with Dynamo is they're not going to charge you based on like an instance with some amount of CPU and compute and, CPU and memory and IO and all that stuff. They're going to charge you based on the actual operations, based on the actual work you're doing against DynamoDB, right? So that the big thing there is knowing about capacity units, which is how you're going to be charged or consuming in DynamoDB. The first one is a read capacity unit. That's an RCU. That means, hey, every 4 kilobytes of data you read with DynamoDB, that's going to be one read capacity unit. Likewise, there's also a read capacity or a write capacity unit where for up to every 1 kilobyte of data you write, you're going to get charged, right? And these are rounded up and also split. You can have multiple of these in a single request. So if you write a 5 kilobyte item to DynamoDB, you're going to get charged for 5 WCUs there. Now, the prices for those are going to be, 12.5 cents per million RCUs, 67.5 cents per million WCUs, and about 25 cents per gigabyte month of storage. Those are the big rates you're going to have. Those are US East 1 on-demand numbers, so make sure you know the region you're in and different things like that as you're doing those calculations, but it's good to just have those available for yourself. The other thing with Dynamo is there are 2 billing modes that you can use, right? So when you're thinking about those billing modes, the first one is on demand. That's the prices I just showed you, where it's pay per request, where you're not paying for anything up front in advance. Basically, just as you issue requests against your DynamoDB table, they're going to be counting how many WCUs and RCUs you're consuming. At the end of the month, they'll aggregate that up and send you a bill. You can also do a provision throughput mode, which is more like use it or lose it, right? Where you provision a set amount of throughput, and every second you have that available for you. And if you can use up to that amount during that second, otherwise it's just gone. Often if you're doing this, you're pairing it with auto scaling, where it's scaling your table up and down based on usage throughout the day, because you probably have some sort of, diurnal pattern or something like that. Between these 2 billing modes, the break-even point is at about 28.8% utilization, so 38% or so. So if you're at provision throughput, you should be utilizing at least 30% of your provision capacity throughout the entire day, week, month, year, all that. Or else, if you're not hitting that 30% utilization mode, then you should switch to on-demand, because it's going to be easier and cheaper for you. And while we're doing these calculations, I always say, hey, use on-demand mode for calculations, because it's easier. You don't have to think about utilization throughout the day and different things like that. You can just think, hey, how many million reads and how many million writes am I actually doing? If you think you can hit better than this 28.8% utilization, add a deflator to that to estimate this stuff, but just use that on-demand to simplify your calculations. So those are the 2 types of cost optimization factors you're going to be looking at in DynamoDB. I think the big implications here is, again, you are the cost optimizer. So you need to be thinking about those when you're doing your planning of your table, to be thinking about that sort of stuff. And while you're modeling, you should be weighing just a few different important trade-offs that come up, right? I think the biggest ones that come up is like, hey, should I add another index? Is it going to help me? Is it going to save me money or time to add this additional index? Similarly, with that index, how much data should I project into that index? How much should I denormalize and duplicate data for different reasons? What kind of complexity is that going to add for me? Whether I should use transactions. These are just some of the trade-offs you should be thinking about with DynamoDB, and a few of these we're going to be looking at as we dive into application. So again, with Dynamo, you're the cost optimizer. It's up to you to be thinking about this sort of stuff. All right, that's just like some background stuff just to get us started in thinking about this sort of stuff. I like to bring it home with an application section, right? Where we're actually walking through some modeling and thinking about these factors and seeing how they actually affect our bill or our application, our users, different things like that. So I want to walk through an application. I was trying to think of what to do here, and I decided on like a food delivery service, right? Something like Uber Eats or DoorDash or Delivery Hero, right? So I had ChatGPT come up with PlateMate for me. That's going to be this logo we have here, right? Which is going to be sort of like Uber Eats, some sort of food delivery service, right? And so as we're doing our modeling, you should first know your domain, right? That's the first thing I always say is know your domain. And the first thing to do there is to understand your core entities. And hey, with a food delivery service, there's a lot of different entities that are relevant, but we're just going to look at one. We're just going to look at the idea of this order entity, where a customer comes in, they place an order. How does that order sort of move throughout our system, and how can we think about optimizing the access patterns on that order, right? So we have that order entity. The first thing you should think about is just like how big is this entity, and think about, right? And I was thinking at first, hey, not that big, but there's really a lot going on that order entity, where you have information like the order ID and a couple different timestamps and a status for that order. But now you also have the customer that cares about that order. So you have the customer ID, the delivery address to which it goes, all the items you have in that order, right? Which if you're doing a big group order, like my family, a big old family, we got to order a bunch of stuff. Everyone has special stuff, special considerations, things they want added, things they want off. Like it's going to just take up a lot of data there in that items array. But in addition to that customer information, we also have the merchant, right? The merchant that's actually going to be fulfilling this order, the restaurant. So we have the merchant ID, the merchant address, things about that merchant, maybe the merchant policies. And then finally, we also have that courier that's actually going to be delivering our item to our end user, right? So we have a courier ID, courier info. We have courier location, right? So if I open it up and want to see where my order is, is the courier at the restaurant? Are they on their way? We have that. And then we also maybe have like a status timeline just to see all the different, as it's moved through different statuses, we have a historical record of what that all looks like. So this starts to get to be a pretty big, beefy item. Let's say like 6 kilobytes on average is what this is going to be, maybe smaller, maybe larger. We're just going to use this for purposes of the example. The other thing you should know is just like, hey, what's the general workload of my item? Right. And it turns out that like a lot of applications are very read heavy, maybe like 100x reads for every write. But some applications aren't. And this one might be a little less read heavy because if you think about it, hey, that order, while it's active, while it's being processed before it's being delivered, maybe we're reading it a little bit then. But as soon as it's, 2 hours old or a day old or a week old, you're not really reading that item anymore. Right. So it's not super read heavy for very long. And then actually there are kind of a lot of writes on this item, especially because of that courier location where every, period of time we're going to update where that courier is. We're going to be doing a bunch of writes to that item as well. So this workload is actually like fairly write heavy, which again, due to that courier location, if you think like a 20-minute order, you're doing like a location update every 15 seconds. So 4 updates per minute. Now we're talking about 80 writes on that item. And then also as we think about how much those writes will cost, right? And a WCU is for every 1 kilobyte of data that we have. So since we have this 6 kilobyte item, that's going to be 6 WCUs per item times those 80 writes we're doing. It's going to be about 480 WCUs we're going to be consuming for this order, right? So at a baseline, that's just about how many WCUs we can expect for our order. So now that we understand our core entities, let's think about our access patterns that we have on our entity, right? And I always recommend writing this out. And for our write access patterns, you have create your order, update the status as it changes, and of course, update that courier location that we talked about. And then the read access patterns are interesting as well, right? Because we have this order item. We also have like a bunch of different views on this order item that we're going to want, right? The customer is going to want to be able to see their particular orders, see the history of their orders and things like that. Same with the restaurant. They're going to want to know order history. Also, like what are the active orders I need to be preparing or what's coming up. And then the courier, of course, is going to want to know their order history and things like that, right? So you have a bunch of different reads on these orders where you have that get order by ID, but then a bunch of these different list order history type access patterns on this order item. And then once you know your access patterns, that's when you start designing your data model. At a base level, hey, since we're going to be creating that order, getting an order by an ID at my base table, I'll probably just use that order ID as my partition key, right? That's how I'm going to uniquely identify my item. I've got that order ID in there, so I'll set it up like that. You can also see I have a couple different timestamps in here. I have like ordered at, which is when the item was actually ordered. Then you also have like effective at, because like, hey, if I order something and want it as soon as possible, that effective at is going to be the same, but I can also schedule orders like, a week into the future. So maybe that effective at is when that order is actually going to be effective and the restaurant should start thinking about it and preparing it. And then we have customer ID, merchant ID, courier ID, those sorts of things. And then we have that courier location attribute you can see there where for orders that haven't finalized, we're sort of updating where that courier happens to be there. So that basic pattern of that order ID for our partition key, that really handles all of our main access patterns. We're always going to have that order ID available, so we can create that order, we can update that order status or courier location as well. And now looking at our read access patterns, we can get that order by ID. That's handled by our base table. And now we need to think about all these different sort of list access patterns, which are additional access patterns on our table that we need to handle. And when you have new access patterns, the big thing you want to reach for here are secondary indexes, right? Where what secondary indexes are basically fully managed copies of your data. Dynamo, when you write an item to your base table, if you have a secondary index, it's going to copy it to that secondary index for you. And what this does is it enables additional read-based access patterns on your data, where you can have different keys that allow you to access your data in different ways. And that's what we're going to be using for that sort of thing. So if we think about, hey, we want to get the order history for a particular customer, right? We can come here, we can create a secondary index where the partition key is that customer ID, the sort key is that effective at, and now we take this data, it's the exact same data, but it's just organized in a different way where now it's grouped by that customer ID, it's ordered by that effective at timestamp, and now I can get items within a particular time range. I can get the most recent order items, different things like that for me, right? So we've added this secondary index to list the order history for a customer. And you might just think, hey, let's go down and add a secondary index for all these different things. But that starts to actually get expensive, right? Because each index is going to consume write capacity units when you write to it, right? So, and we've already seen, hey, we have kind of like a write heavy application. We're doing 480 WCUs on a given order item. If we're going to be doing that to all these different indexes, that's going to cost a lot, right? We have our base table, which is going to consume 480 WCUs. When we add this customer index on there, right, we're going to consume another 480 WCUs. And if we do that, if we create indexes for each one of these access patterns, we're going to create using 480 WCUs for each order item. That means now we've blown it up to 2,400 WCUs for a given order, right? And that can actually get expensive, and start thinking about that stuff. So that's where I want to get into. Now we've done that setup, like how can we optimize this? How can we be a cost optimizer, a query planner to be thinking about this while we're modeling, right? So there are a couple of different index optimizations you can do. The first one is question, hey, do I actually need that index after all? Is that index giving me value, especially the value that I'm paying for it, right? So let's look at our next two access patterns, which are both for the merchant, right? The restaurant. They want to be able to see their order history, so see all the past orders they've done. And they also want to see, hey, what are the active orders I need to be processing? Maybe they're putting that up on a board in their restaurant so people know to be processing that sort of those orders as they're coming in. So for that first one, right, that order history one, we'll do an access pattern very similar to that customer index that we just had, where we use a partition key of that merchant ID. We use that effective at as the sort key. And now we've got this secondary index where they're grouped by that merchant ID and sorted by that effective at, right? And that gives us order history. We can see the most recent orders they processed. We can see historical ones. We can look by month, whatever we want to do there. So that will handle that one. And now let's think about a little trickier one, is listing active orders for a merchant, right? Because if we go look back at our table, what we want, we basically just want to have orders that are not finished, right? So we have a few orders. That second to last order is in the status of preparing. The other one is en route to customer, right? We only want the ones that are not finished to be showing up there. We don't care about ones that are delivered or expired and all that stuff. We don't need to show that on the big board. And so one pattern you might use to solve this is the sparse index pattern, where this is a filtering strategy based on like the presence or absence of an index key attribute. Because when you create that secondary index, you're going to specify the keys that you're using for that secondary index. And if you have an item that doesn't have those particular keys on it, it's not going to get copied over to that secondary index. It's just going to get filtered out for you. And this can be really useful for a lot of different things where, you know, we only want to be copying over those active ones. So what we could do is add a new attribute on our table. Let's call it like active effective at. And this is basically the same value as that effective at, but in our business logic, we only put this attribute on our item while it's still in an active order status, right? And once we have that, so you can see like, you know, only ones that are not expired or delivered have this particular thing. And now we can set up a secondary index on this. And now we have this sparse index, which allows us to list active orders for a given merchant, right? And it's keyed by that merchant ID, and it only has those active orders in there for that, right? So that's a sparse index pattern, which is a great pattern for a lot of things. It can be used to save money, but not always, right? It can also just be used as like a general modeling technique. You sort of want like a global filter on your table. That's what that sparse index can do. And if we look at it in our case, it's probably not going to save money, because if we think about all the writes we're doing on this table, the bulk of those writes are going to be all those location updates that are happening every 15 seconds, right? That's really what's blowing up our write costs. And in this case, if we're just projecting active items into that, those are ones that are going to be getting those location updates. So we're not actually saving that much money by having this sparse index. So it can be a useful pattern again, but it's probably not going to save us that much money. But one thing we can look at and say, hey, let's look at that previous index we already had. We had that merchant order history index. And if we look at that, right, it's already grouped by the merchant. It's sorted by that sort key. And if we look at the orders that we want, the active orders, those are always going to be at the end of our item collection. Those are going to be the most recent orders, right? There aren't going to be any active orders that are a day old or a week old or a month old that we need to look at. Or even if they're in some bad status, we don't really care about them. We shouldn't be preparing them, because you don't want to deliver an order a month late to a customer anyway, right? So really, if you look at this, there's like a very high correlation or overlap between the order history and especially like the most recent orders and which orders happen to be active for our user, right? So given that, we can actually just get rid of this active orders index altogether and use this merchant index for both of these, right? Because we know our active orders are going to be our most recent orders for this. So now we've entirely eliminated an index for you, and we've dropped that. It used to be 2,400 WCUs for this order item. Now we're down to 1,920 WCUs already. So that's the first pattern I would say you can think about is just reuse secondary indexes when you can. I think this is useful in two different situations. One is when there's like a very high correlation or overlap between your read patterns. Like we're saying, hey, we're already organizing these orders based on when they're effective. And that happens to overlap really nice based on active orders because the most recent ones are going to be effective. But you need to be careful here because sometimes like pretty high overlap, there might be pretty high overlap, but not enough that you can actually reuse the index. And the example I think of is like an email inbox where I want to see my unread messages, right? In my email inbox, maybe all my messages are sorted by when I receive them. And it's more likely that my unread messages are going to be my more recent ones. But I also have an email that I've marked unread from a week ago or 2 weeks ago or 3 months ago, just like as a to-do of something I need to come back to. And given that there's like a high overlap between those, but not high enough to where I want to, I can count on that to get exactly what I want. In that case, you probably need to use a sparse index to get unread messages to filter those down. A second time you might want to reuse secondary index is when just like the overall search space is pretty small and it's worth it to just overread and then filter rather than create a secondary index for it, right? So think about if you have like a multi-tenant SaaS application, each organization is going to sign up. They're going to have lots of different users in there. And sometimes you have an access pattern that says, hey, get me just the admin users for this or some sort of filter on those users. If that search space is pretty small, you're only going to have a max of like 100 users within a given organization. It doesn't make sense to create that additional secondary index, that additional view on those users. You can probably just grab all the users for that organization and then do the filtering and save all those write costs on it, right? So it's hard to know how big that search space has to be. But my rule of thumb is like, hey, if the overall search space, all the users for this organization, if that's less than 1 megabyte, that's one DynamoDB query page. I think it's worth it to just like sort of overread in that case and do the filtering rather than pay for that secondary index. All right. So that's our first way to do some optimizations. Like, hey, do we really need that index after all? Can we reuse a different index or just do some overreading and filtering within a small search space? The second thing is, hey, in that index, do we need to project the entire item? And this is something I overlooked for a while, and now I really appreciate a lot more, where when you're creating a secondary index with DynamoDB, you can choose how much of that item to project into that secondary index, right? And I always used to say, hey, just project all. It'll be much easier. You can just read it and you'll have all that data available for you. So you can project the entire item if you want. You can also, at a minimum, just project the keys into that secondary index, which will mean, hey, it'll have the keys for your secondary index. It'll have the keys for your base table, but it won't have any of the other attributes on there. And then the last one is you can do include, where you can say, hey, include these specific name attributes and project those into that secondary index. And you can almost think of this like a covered index strategy with a relational database if you're into that sort of thing. But the biggest thing I would say is like, hey, you can have significant savings from not projecting all of the attributes into your secondary index. And the best way to think about this is like, I actually this is my Uber Eats history. I don't order Uber very often, but when I do, like, hey, the last 2 times I've ordered Uber, like if I look at my order history, like that customer history read pattern we have, you notice it doesn't really show that much information just on the list view page, right? It has like an image URL. It has the name of the place I went. It has a date. It has the amount and the number of items, things like that, the order ID, but it doesn't have all the information about the restaurant and where it was and the courier and all my items and stuff like that. And if I actually click on this in my application, you can see it spin as it goes and gets the order by the ID and fetches and hydrates that entire item, right? So this is like a subset of that item. So going back to that customer index that I had before, I don't need to copy all of this data, right? I can have a much slimmer item that I'm projecting into my secondary index that can handle just that list view for me. It's a lot skinnier there. And so now if we go back and look at our chart in terms of how many WCUs we're consuming on this, hey, maybe for that customer index, instead of having a 6 kilobyte item, I only have a 1 kilobyte item, right? And now I'm only consuming 80 WCUs per item in that secondary index rather than that full 480. And I can do the same thing with the merchant. Maybe I skinny that down to 3 kilobytes, and the courier, I slim it down to 2 kilobytes. And now I've taken that 1920 WCUs, I've cut it in half, and I'm down to 960 WCUs, right? And so this can be a really effective strategy for you where you think about, hey, what attributes am I actually going to need in my secondary index, and only project those ones rather than projecting that giant fat item for you there. Now, that's going to save us some money, but it's not going to save us as much as we want, right? Because what we're doing is we're slimming down the number of WCUs we have per item. But what's really blowing up our write cost is the number of writes we have in that item, right? And that's what's getting it for us. But we can also use projections to save us money here, where, hey, if we're talking about the merchant probably doesn't need to know that courier location. It doesn't need to get updated every 15 seconds for where that courier is. All it needs to know is I need to prepare this order, have it done by this specific time, and someone is going to come pick it up and handle that, right? So I can actually not project that courier location into that merchant index. And now I'm really slimming down the number of writes I'm doing into that merchant index. Now I'm only doing maybe 8 writes, or, when the status changes and stuff like that. And because of that, instead of using 240 WCUs in my merchant index, I'm only using 24 WCUs, right? And same thing with that courier index. They probably don't need that information projected. The courier knows where it is. So you can slim that down as well. And now we've gone from 960 WCUs down to 600 WCUs, right? So those secondary index projections, I'd say it's really worth thinking about that in 2 ways where you can get the savings, right? You can reduce the number of WCUs consumed per write when you're saying, hey, I'm actually writing to my secondary index, but now that item is smaller, so I'm consuming less WCUs for each write. But the bigger savings that we're seeing here is when you're preventing certain writes entirely, right? For that merchant index, for that courier index, we're not rewriting that item every single time that courier location changes, and we really cut out a lot of the writes we have in our application. And I would say at this point, we still did project it into that user index, right? Because the user does need to know where the courier is, we think. But that gets me into the third optimization that we can think about here is, when are sequential operations okay, right? Because we talked earlier about optimizing DynamoDB latency, and one thing you want to do is avoid sequential requests. And I'm thinking as a user, if I'm looking at my order, I do want to know where that courier is, but maybe I don't need to copy it into that user index, because if I think of my user history page, right, I don't need to know the courier location there. I only needed to be knowing that courier location while that order is active. And maybe what I could do is in my customer index, maybe I don't replicate that courier location in that. But if I fetch it and I see I have an active order, then I can go back to that order, fetch the courier location, and display it to that user, right? So what I'm doing is I'm reducing the amount of data in my customer index, but realizing, hey, if there's an active order, I'm going to have to make a follow-up, a sequential request to hydrate that full item. So I'm trading off a little bit slower read pattern in this specific case to have a cheaper write pattern here, right? So in that particular case, I'm reducing the number of writes, just like I did from a merchant index and my courier index, down to 24 WCUs consumed. And now I'm down from 600 WCUs down to 544 WCUs. And as we work through these different patterns, when thinking about whether sequential operations are okay, just consider how it fits within your latency budget, right? You don't want to get into the habit of having to read some items from the secondary index and then go hydrate it from your base table. But if it's only hey, a 2-level waterfall that you have to do there, that can be fine, especially if it can save you a lot of money on that secondary index. That can work for you. And the big thing I would say is looking back at that table, hey, we started hey, this was at the naive way for using 4 secondary indexes and duplicating all that data in. That's going to cost 2,400 WCUs to handle one order item over its sort of life cycle. And we cut it down to 544 WCUs just by, hey, reusing index where we can, projecting less of that item, and being okay with sequential operations in certain aspects, right? So with that conclusion, I just want to wrap up here. I think you are the query planner, and this is super powerful for you, and you should take that on. And I think it's kind of fun to do some of this math for you and do some of that bottom up analysis of hey, what is the best way to actually model out this data? There are a lot of different things we can use, and consider those trade-offs carefully, right? We just focused on index in this particular thing, but there's also read versus write optimizations, especially because writes are basically 20 times more expensive than reads, right? Because a WCU is only 1/4 of the size of a RCU, but it costs 5 times as much. So you really want to trade off, hey, faster reads are good for my users, but also I want to save some money based on those writes. Also think about transactions, right? Dynamo has transactions, but it adds cost, it adds contention on your item, and you should be considering these trade-offs and understanding these things. Global tables, another great feature of DynamoDB, but it does, essentially double your bill. So be thinking about when to use those sorts of things. The biggest thing I would say is do the math, right? We just talked about indexes here, but you can take these billing patterns, you can take those cost latency patterns and be thinking about that and apply it in a lot of different situations. Take out your pencil or your Excel spreadsheet and do some math, and you can get a pretty good estimation of how you can optimize your tables.
All right, awesome stuff. All right, Alex, I see you in the green room, about to go live. If you haven't asked your question yet, make sure to go to the Q&A and polls tab to the right of chat and put your question in there for Alex. All right, Alex, let's do it. Hey, Alex, welcome back. Great session.
Thank you. Thanks for having me. I tried to wear the same clothes so it wouldn't be jarring for people since it was pre-recorded. So I see a lot of great questions in there. So thanks everyone for this. And happy to dive into them. Do you want me to sort of take team up? Do you want to do it? What's the best way to do this, Joe?
So I'm going to bring up the questions for you. And then if we have anything in the chat that we missed, sometimes we lose information in the chat. So if there was a really good question asked in chat and you answered it, I probably would like to bubble it up here as well. But let's get to the first question we have in Slido. When would you choose a single table design over using separate tables for each entity? Since DynamoDB doesn't charge extra for additional tables, what practical benefits does single table design provide compared with multi-table approach?
Yeah, this is a great question. And this is one I've definitely evolved on too. I know when I got started with Dynamo, I was very much all single table all the time. And I'm more nuanced on that. And I'd lean towards more tables generally. I do like single table in that it helps teach you how Dynamo works and how to think about it and really think access patterns first and think about accessing your data separate from the rest of the attributes that you store with your data on that. My general rule is, hey, Dynamo has this really powerful operation, this query operation, right? Where you can get a set of records that all are in the same item collection, that all have that same partition key, whether that's in your base table, whether that's in your secondary index somewhere. And there are some optimizations you can do, whether it's vertical sharding, which I saw Ivan had a great question about this I want to go to in a second, or whether it's pre-joining data, right? If you have a hierarchical one-to-many relationship and maybe you want to pre-join them together so you can fetch them all in one request. If you have some access patterns where you have that different types of entities in a single request, I would say hey, use some of those single table principles where you're grouping them together. But the whole point of single table is I have at least one operation where I'm using that query to fetch different types of items in a single request. Now, if I never have that type of use case, if I'm always fetching, hey, just a single type of item, just the order items, just the orders or just the users or just the merchants or whatever, and I never need to get different types of entities, the benefits from single table are less strong now, especially since on-demand billing is there. On-demand has gotten a lot cheaper, right? They had a 50% price cut last year. So it's fewer, you don't have to do that much management of capacity on that. Auto scaling has also gotten really good. So I think the benefits are getting smaller there. And was it Christian that asked this question? Like he said, there are some benefits to separating out into separate tables where you can have it's easier to sort of handle streams, right? If you have different types of items and want to be doing different things with them, if you want to have different TTL policies or global table policies or backup strategies or whatever it is, there are some benefits to having multiple tables. So I've tried to tell people, hey, if you're doing some of those optimizations where you're getting different types of items in a single request, hey, then you have to use single table. That's what that's for. But otherwise, don't be afraid to split it into separate tables and just maintain that conceptually easily thing. The one thing I want to say is, hey, don't just rebuild an RDBMS on DynamoDB. The bigger thing is hey, make sure you're thinking about smart denormalization, whether that's duplication, embedding of some data, things like that. That's the big part you want to get to. And then thinking about your access patterns first, I think are the big things there.
Excellent.
Great question.
Yeah. So I don't know, did I even ask the question in the chat about sharding?
No, it's the first one. I see it in there. Ivan. Yes, this is a great question, right? So if you really look at the problem we had set up here, what we had is this large sort of order item. It's 6 kilobytes. And we're doing a lot of updates on it for this one specific thing, just the location of that courier, right? And that's what was causing a lot of that WCU, a lot of that churn of that item and things like that. And I liked using that example to show that principle of, hey, like, don't just automatically slap a secondary index on it and think about projections and all that sort of thing. I think it's a good principle. But Ivan also has a great point here of just like, sometimes it makes sense to what we call vertically shard an item, where you might have most of the order, sort of the larger, slow-moving stuff all together in this order item. But then you might have a separate item that's just the order location, right? That maybe you put in the same item collection. So if you want to fetch them both together, you can still present that to the user almost as one unified item. But then when you're just changing that location item, then it's just a small number of bytes. It's only going to cross one WCU. You don't have to replicate it into any secondary indexes, things like that. And you can actually save a lot that way. So yeah, that vertical sharding strategy, that's a really great strategy as well. You're getting into some of those like single table-ish principles. So make sure you understand those well before you do it. But that's a really great point there as well from Ivan. So I love that one.
Another question coming in. It's a little slow. The question was from Theo that says, an existing company which feared DynamoDB due to the naive usage, what would be your recommendation to overcome this fear of innovation?
Yeah, it's a good one, and it's one I've struggled with over the years. And I used to like really fight it with people and be like, "Hey, man, like this is you should really be thinking about this and do this." You sort of got to pick your battles in some sense. So like some people are they want to rely on their tried and true, and if that works well for their situation, I think that's okay. The one thing I do like about learning and seeing, like, Dynamo has such a unique perspective on data that I think no matter what database you're going to use, I think it's worth learning Dynamo and sort of understanding the constraints, understanding how those constraints are good and can be good for you to even if you stick with Postgres or MySQL or whatever else you're doing. So I would say, like, at least try and get them to learn it. Maybe you do like a lunch and learn and say, hey, here's some cool stuff about Dynamo that we can use. I also like to say, hey, can we pick off a small aspect of a project that it fits really well? If it's like an audit log or some sort of event tracking that's like, hey, it's like a pretty flat schema. It's growing really large, just taking up a bunch of room in our table, or maybe it's a new application we're going to have. Like, that's a great use case to get started with Dynamo and at least like get your feet wet. I don't think you have to go all the way down the rabbit hole, but like I would say, like, evaluate it and make sure it works well for your needs. Like, what you don't want to get is a situation where people are scared of it. You try and shoehorn it into a situation where it doesn't work well. Maybe you need a lot of complex filtering and different things like that, which isn't going to be Dynamo's sort of strong suit there. And then everyone's unhappy, right? You're unhappy, they're unhappy. Like, so make sure you find a good use case. And I would say, like, hopefully you've got some colleagues that like want to learn some new stuff, even if they don't want to apply it right away.
Excellent. Okay, next question. How often do you think about TTL attributes to reduce storage cost?
Oh, TTLs are awesome. I would say, yeah. Basically, the way the Dynamo TTL works is on your table, you can set a TTL attribute. And if you have that attribute on your items and it's a timestamp, they'll just sort of look at that occasionally and clear out old items from your table. Great things about TTL. Number one, it's like it says here, it's going to reduce your storage costs because you're not keeping that item around anymore. So it's good to like clear stuff out of there. The second thing is they don't charge you for the right to delete that item. So it can be a great way if you were going to go manually sort of clean these out every once in a while. Now they're doing it for you and you're not charging for the right costs, which is awesome. So I would say there's certain types of data where you're like, you know what, this data is useful for a week or for a month or some specific amount of time. But beyond that, it's not really useful. I don't need to keep it around anymore. Maybe it's sessions or something like that. Maybe it's idempotency tokens, whatever it is, so there's some stuff you don't need to keep around. TTL is a great way to do that rather than doing it yourself and paying the maintenance costs and the actual write costs to delete those items. So yeah, strong recommend on TTL.
Great. Probably time for one last question. Eduardo wants to know, do you recommend DynamoDB for brand new projects? Usually in this scenario, we are still discovering the access patterns, and changing that with DynamoDB does not seem like an easy task.
Yeah, great question, Eduardo. I get this one a lot. I think there's a lot of fear around like, hey, with Dynamo, I can't add new access patterns. I can't do stuff like that. I think that's sort of overblown. If you're going to be at reInvent, I've got a couple chalk talks on it. I'm going to include it in my breakout session as well around like how you evolve these Dynamo projects. The bigger thing I would say is there are certain things that are hard for Dynamo no matter what, no matter if you know on day one or if you find out 6 months later on it. And I would say the big one would be like complex filtering, what I call complex filtering, where if you have some sort of set of items like order items that we're talking about, and you decide you want to give customers the ability to filter on like a bunch of different attributes, maybe order in a bunch of different ways, do different sorting, all these attributes are optional. And it's like a fairly big set of data for that particular customer or merchant or something like that. That's a little hard for Dynamo to handle, to have that much flexibility. In that case, like you're almost always going to want to pair it with like OpenSearch or some other type of like flexible querying engine. And that's always going to be hard. And I find that a lot of times when I find people say like you can't add access patterns after the fact, what they really are upset about is this particular thing. Like, hey, I can never get that sort of like flexible querying, complex filtering type use case. And that's sort of true. So that's the big thing I would say. If you're starting a new project and you think, hey, down the line, we're going to need sort of a lot of these like complex filtering type use cases, that's like a tougher one to think about. And you need to think about, well, do I want to pair Dynamo with something else? Or do I want to use something that maybe is better for that in certain cases, but loses some of the operational benefits of DynamoDB? And that's sort of the trade-off there. But if it's really just like, hey, we're going to add some new access patterns or change our schema a little bit, usually you can handle that with Dynamo pretty well.